In this video, we'll be evaluating this summation for different values of n. Okay, so basically what we're asking for is if n equals 10, if our summation ended at 10, such that we had I plus 1 divided by 10, how would this summation differ if I plugged in 100 or 1,000 or 10,000? Now we can actually go through this and we can plug in 1 like we did in the first video. Plug in 1, then plug in 2, then plug in 3. But once we got up to even the second case where we're plugging in 100, that's going to get really tedious and time consuming. So what we're going to do instead is we're going to return to the concept that we did before. We're going to look at this summation right here, and I'm going to tear it apart. Okay? So first step I'm going to do is I'm going to say, hey, this is 1 over n squared, is it not? So this is a summation of I equals 1 to n of 1 over n squared times I plus 1. Next detail I'm going to make note of is that I can factor out n squared from that summation. Again, it's not necessarily a constant, but it behaves like one when the index variable is not anywhere near it. Okay? So that's going to provide me with I plus 1. Next thing I can note is, if I look at example number 4, or the theorems from number 4 one more time, we'll have the case for a constant, and we will also have a case for a single power of I. So if I get just the summation from 1 to n of I, then this is what that thing is going to be equal to. So let me go ahead and rewrite this one more time, throw brackets around that summation. This is equal to 1 over n squared, a summation of I equals 1 to n of I, plus, because the plus sign, the summation of I equals 1 to n of 1. So now, this is the concept that I'm working with. Keep in mind, this summation right here equals to something very specific, and this summation also equals to something very specific. This one here is just c times n, where c is 1. So this is 1 times n, plus, and this one right here is I. Well, again, this is nothing more than a formula. If I can identify that it looks exactly the same as this, then it is exactly the same as this. So my formula is n plus 1 divided by 2. Again, look very closely. Summation of I equals 1 to I, so 1 to n of I. The summation of I equals 1 to n of I. That's this thing right here is equal to this thing right here if I evaluate that summation. So I'm going to end up with n plus 1, all divided by 2. That is what's inside my brackets, multiplied by 1 over n squared. And now my step is to go ahead and simplify this summation in its entirety if I can. If I do at least a little bit of simplification, you'll notice that I'm going to have the n here and the n here cancel out, leaving me with n plus 1 divided by 2n, because there's an extra n left over if I distribute this to this first term. Then plus 1 times n over n squared, or plus 1 over n. So now this here is the formula for this summation. No matter what n is, this is my formula. Which you'll notice, if that's the case, this thing is nothing more than 11 over 20 plus 1 over 10. Again, all I did was in here replace my n's with 10. All three of these n's right here I replaced with 10. So this value right here, if I simplify it just a little bit, is 13 over 20. And that's what this first summation is, if I add up 10 terms. What if I did 100 terms? I equals 1 to 100. Well, in that case, again, all I'm going to do is use this formula down here, but replace all my n's with 100. Now, if you want to make this a little bit easier, you can simplify this formula a little bit, doing n plus 1 divided by 2n, plus 2 over 2n, giving you n plus 3 over 2n. By doing so, when I plug in 100, I only have 2 n's to plug it into, and I get 103 over 200. If I wanted to go for 1,000, I equals 1 to 1,000. I'm going to end up with, and I'm going to go ahead and just bypass writing the function, I'm going to have 1,003 divided by 2,000. And you'll notice that I can simply evaluate every single one of these values with mild amount of work and no calculator whatsoever. Okay? That's how you're supposed to evaluate these sums without using a calculator, utilizing summation notation and the appropriate formulas and properties.